In this video, I will walk you through free response question number 5 from the 2022 AP Calculus exam. This problem is primarily about slope fields and differential equations. Consider the differential equation dy dx equals 1/2 sine of pi over 2x times the square root of y plus 7. Let y equals f of x be the particular solution to the differential equation with the initial condition f at 1 equals 2. The function f is defined for all real numbers. Part A. A portion of the slope field for the differential equation is given below. Sketch the solution curve through the point 1, 2. Start at the point 1, 2 and follow the slope field lines like a leaf floating on a current. And it might look something like this. If you drift with the current of the slope field in the opposite direction, it might look something like this. That's really it for part A. Part B. Write an equation for the line tangent to the solution curve in part A at the point 1, 2. Use the equation to approximate f at 0.8. Whenever they ask us to write an equation for a tangent line, we love to use point slope form because it reminds us that all we need is a point and the slope. For a point on the line, we can just use the point of tangency, 1, 2. We know that the derivative gives us the slope of a curve at a point. To find the slope of the tangent line, we need to evaluate the derivative at the point 1, 2. Substituting 1 for x and 2 for y gives us this. The square root of 2 plus 7 is the square root of 9, which is 3. That 3 will end up in the numerator, so we will have a 3 over 2 in the front. But then we have the sine of pi over 2. That's 1. So really, we just have 3 over 2. So that's the slope. Now we can write the equation of the tangent line. It goes y minus y, so y minus 2, is equal to the slope, so 3 over 2, times x minus x, so x minus 1. Let's go ahead and add 2 to both sides. So we have y is equal to 3 over 2 times x minus 1 plus 2. Next, we will use the equation to approximate f at 0.8. This problem is not calculator active, so I recommend that you leave your answer just like this. If you did simplify, you would get f at 0.8 is approximately equal to 1.7. Part C. It is known that f double prime of x is greater than 0 on the interval from -1 to +1. Is the approximation found in part B an overestimate or an underestimate for f at 0.8? Give a reason for your answer. If a function is concave up on a given interval, a tangent line approximation will always give an underestimate because the tangent line will always be below the curve on that interval. If a function is concave down on a given interval, the tangent line approximation will give an overestimate because the tangent line is always above the curve on that interval. Looking at the graphical relationship between f, f prime, and f double prime, we know that f will be concave up when f double prime is positive. So the approximation in part B is an underestimate because f double prime is positive on the interval from -1 to +1. So f of x is concave up on the interval from -1 to +1. So the tangent line is below the curve. Do we have to say all 3 of these statements to get full credit on the AP exam? Honestly, I don't know. I've seen it answered different ways at different times. If I were you, I would say all 3 statements just to be safe. Part D. Use separation of variables to find y equals f of x. The particular solution to the differential equation dy dx equals 1/2 sine of pi over 2x times the square root of y plus 7 with the initial condition f at 1 equals 2. Separation of variables means we need to get all of the y factors on the left and all of the x factors on the right. We can move the dx over to the right by multiplying both sides by dx. So now we have this. Let's move the square root of y plus 7 factor over to the left by dividing both sides by radical y plus 7. Now that we have all of the y factors on the left and all of the x factors on the right, we can integrate both sides of the equation. I'm leaving the 1/2 outside of the integral. The left side will be easier to integrate if I rewrite this fraction as y plus 7 to the negative 1/2 power. To integrate the left side, I will use a mental u substitution. I'm thinking of y plus 7 as u. In that case, u prime is just 1. So normally we have to be careful to divide by u prime, but dividing by 1 changes nothing. So I'm just going to go ahead and integrate. So using the power rule for integration, I'm going to add 1 to this exponent, and I get y plus 7 to the positive 1/2 power. Then I divide by the new exponent. Dividing by 1/2 is the same as multiplying by 2. We will save the constant of integration for the right-hand side. Let's do a u substitution. Let u equal pi over 2x. So that gives us sine of u. Instead of dx, we write du divided by u prime. So du over pi over 2. But dividing by pi over 2 is the same as multiplying by 2 over pi. So now we have this. On the next step, the 2's will cancel each other out, and we will have 1 over pi. The antiderivative of sine is negative cosine. I'm going to put the negative right here, and then we have the cosine of u, which is pi over 2x, plus c. We can use the initial condition f at 1 equals 2 to find the value of c. Basically, when x is 1, y is 2. So here I have substituted 1 for x and 2 for y. The cosine of pi over 2 is 0. So that means this entire term is gone, and we just have c equals. 2 plus 7 is 9. The 1/2 power is the same as the square root. So this is really the square root of 9, which is 3 times 2, which is 6. So c equals 6. Substituting 6 back in for c, we have this. We were told to find y equals f of x. That means we need to get y by itself. Let's do some algebra. On the next step, I will divide every term by 2. So I will end up with a 2 pi in the denominator, and this 6 will become a 3. So now we have this. I can get rid of the 1/2 power by squaring both sides of this equation. So now we have this. To get y by itself, we just have to subtract 7 from both sides. So this is the final answer.